Alright, last example type in 110. This is called a dual investment. So you get this much money and you have to put it into these two accounts. Alright, one's going to pay this amount, one's going to pay this amount. And we want to know how much interest is going to be given as a function of the amount invested at 6%. Okay, and we want to use X for that. Alright, so thinking about this, if I invest X dollars at 16%, I'm using the interest formula. Interest is equal to principal times rate times time. Okay, now this says the first year, so that means T equals 1. So we really don't even have to write it, because we multiply by 1, you get the same thing out, so I can just do principal times rate. So the interest in the 6% account is going to be the principal, the amount that we put in there, X, which is what we don't know, okay? The amount of money invested at 6%, which is X, that's our principal in 6%, times the rate, which is 6%, so I'm going to write it as 0.06. So the interest from the 6% account is 0.0x, or 0.06x. Alright, now I do this exact same thing. Interest equals principal times rate, again since time is 1, for the 8% account. Now, if X is what I put in to this account, to the principal, and I had 16,000, then I have 16,000 minus whatever I put in to this account left over. So, for instance, if I put in 10,000 here, 16,000 minus 10,000 is 6,000 here. 10,000, 6,000. If I put in 8,000 here, I've got 16,000 minus 8,000 is 8,000 goes here. 12,000 from 16,000 is 4,000. Okay, so whatever I put in here, 16,000 minus that is what I have to put in here, times 0.08 is the rate here. Alright, and it's the only thing that we're going to do differently at all than this one is just distribute this through and simplify. Alright, so distributing the 8% through, I get 1,280 minus 0.08 times X is minus 0.08X. Now that's from the 8% account. Okay, so what am I going to do? I'm going to take both of these two and I'm going to add them together, and that's going to be the total amount of interest as a function of the 6%, okay, X. So I is the name of the function, X is the name of the input, so I'd write it that way, equals, and then I'm going to add these two together, 0.06X plus 1280 minus 0.08X. Alright, but because this right here and this right here are like, I can simplify it and it decreases. So 1280 minus, if I add them together, 0.02x. Okay, now if you look at it, think about it for a second. 8% is more than 6. Okay, so our maximum amount, this is a line, right? So our maximum amount would be, our maximum amount of interest would be 12,000 or 1,280 if I invested none, 0. If this were 0, I'm not subtracting anything because that times 0 is 0. Now I would end up with this number. Well, X is the amount we invest at 6%. So if I don't invest any at 6%, meaning all of it gets invested at 8%, that'd be the most interest I could get. But as X gets bigger, as long as X gets bigger and bigger and bigger, we're losing a little bit of interest, what we could have made. So as X gets bigger, the amount we invest at 6%, we're going to subtract away from this 1,280 that we could have made if all of it had gone in the 8%. Alright, which makes sense. Alright, so that's your last example from section 10. A lot of different word problems. There's no just one way to set up one of these. It takes practice. It takes understanding of how to do this um, relate both. There's more than one variable here. There's amount going at this rate and amount going at this rate. Being able to relate both in terms of the same variable takes some time, takes some practice getting used to. But you should never have more than one letter in your finished expression. You should only have just that one variable that they tell you to use.